Welcome to another installment of our McCrometer webinar series. Today's topic is remote metering locations in aging municipal systems. I'd like to introduce our presenter, Tim Dorr. Tim, how are you today?
Hi, Lisa. I'm well. Thanks for asking. How are you?
I'm doing great. Thank you. We're excited about your topic today. Why don't you tell us a little bit about yourself and what you're going to be covering?
Absolutely. Thanks. So I'm the vertical marketing manager for Municipal for McCrometer. I work extensively with a team in the international team and the team in North America, working with our channel partners on applications and products to suit those difficult applications that they find themselves working in on the clean water and drinking water and wastewater application systems. So today, I'm going to take you through the webinar series. We're going to look at remote metering locations in aging municipal systems. So we're going to have a quick introduction on who we are as McCrometer, some of the challenges that are facing us in our aging municipal systems, how remote metering can help, predominantly looking at utilizing the FPI and ProComm Go, and then a quick overview of the FPI and some questions. So who are we as McCrometer? Well, ourselves as McCrometer, we're one of the businesses that feed into the water quality platform within the Danaher brand. Some brands you may recognize in there like Hack, Trojan, Chemtree, example. We all feed into that system working on the Danaher business tools model. So the markets and areas that McCrometer serve, excuse me, are ag, muni, which is clean water and wastewater, industrial measurement process, as well as oil and gas. We're headquartered in Hemet, Southern California. We have our own calibration and test facility. We've been there since 1955. We actually manufacture, R&D, test, and make all in the US. So everything we build is built America. We individually wet, calibrate, and test each of our meters, and we have the capability of doing that on two world-class NIST traceable calibration systems. We can do small size from 1/2 inch to 14-inch diameter meters on site. On our other sister calibration rig, we can go up to all the way up to the largest we calibrate is a 138-inch FPI flow meter. We're also ISO 9001 and ISO 17025 certified. So what are the challenges that we're facing today in our aging municipal system? And some of these are quite striking and quite poignant and current with what's happening in America at the moment. We've got some real challenges in terms of actually how old our systems are and how much investment that we've actually put into the infrastructure in the last 15 to 20, 30 years. This is all now starting to come to a bit of a head. Because we've got such an extensive array of infrastructure, so as you can see from the ASCE call out cards there, 170,000 drinking water systems across the US, 700,000 miles of public sewer, often in the situation where they're over 100 years old. We're getting main breaks, we're getting utility issues, we're getting contamination issues. We've got obviously lead pipe replacement problems to think about on the small size pipes, as well as actually capacity and the need for more as the country grows and our infrastructure is put under more and more pressure. So we know we've got that need for investment. And in the last obviously 6 months, we've been delighted to hear about the Infrastructure Act and the water bill and how more investment's going to go in. But we're still going to need much, much more. So the challenge we've got is we've got such a growing population, an aging infrastructure, and limited resources in terms of being able to manage and cope with the work that we need to do on the infrastructure. So what do these challenges look like from an everyday operator's point of view? Well, as I mentioned, we're seeing more and more line breaks on older network areas. pipes that are over 100 years, over 120 years old. We're well regarded across the globe as having a very good utility municipal infrastructure in the States. And what we need to try and do is access, understand, and monitor and measure how we can improve, how we can replace, how we can understand the network and the challenges that we've got going through from the clean side. So whether we're understanding the investment which is needed on our current assets, so whether that's main pipelines, whether that's actually distribution trunk mains, or in fact actually our water treatment plants. The challenges is right across the network. We've got water treatment plants that were built in the early 1900s. They were destined to cope with a population size which has now grown more than 15 times what some of them were actually built for. So the challenge has always been, do we continue to invest in older plant? Do we replace plant? Do we do an addition to a plant? And the challenges that brings. We obviously want to be able to measure it. We want to be able to monitor it. We would like the data from it so we can understand the impact that it's having. At the same time, we've got to think about our sustainability, our quality, and the impact, environmental impact that we're having on our planet, on our community, and in our local area, and how that will allow us to be able to grow and nurture for the future. One of the ways that McCrometer is helping us do some of those challenges and measure those almost immeasurable points from before, if we look at remote metering in terms of our aging application, McCrometer uses technology called the FPI, which is a full profile insertion flow meter, and it has the capability of almost being installed virtually anywhere. It can be installed right up into a remote reservoir location where we're getting runoff water. It can be used at the plant, booster stations, pumping stations, filtration, backwash, and all the way into our distribution trunk mains and our DMA areas. The ability to be able to have a insertion device where we don't need to shut the flow off actually allows us to be able to cope with some of the real challenges that we're seeing in the municipal areas in terms of remote monitoring. We've got an aging infrastructure which predominantly has equipment or assets within it, such as valves, such as other equipment that we don't want to either operate or move or replace. But we can't isolate a main or product to be able to shut the water off. So our only way of getting a measurement point is to maybe use an insertion technique and actually insert onto the main line and put a flow meter in that can pull the data and information off. That's where the FPI comes into its own. So the really neat thing now is we've the ProComm Go, which is the ProComm Go is the battery-powered version of our already well-established ProComm transmitter with the FPI. It allows us to be able to measure in absolutely very remote locations. So it's locations in terms of reservoirs or treatment plants, all the way through to lakes, storage reservoirs, etc. So we can use the ProComm Go from a reservoir, a treatment plant, and also adhere to as a remote location. So how is the FPI meter made up and how does it work? Well, the primary element, the sensor, if you like, this is the measurement part of the flow meter that's physically installed into the pipe. This comes in contact with the water, and this element contains the coils that generate the magnetic field and actually use electrodes that measure the voltage. Different to a standard electromagnetic flow meter, the FPI, or full profile insertion, actually has multiple electrodes, and it measures the velocity all the way across the different electrodes. That's in accomplishment with the second element, often referred to as the converter or controller, or in our case, more often as transmitter. This is the portion of the meter that receives the signal from the sensor or the primary element and converts that into a usable format, such as a flow rate. So for us, we take the velocity measurements look at the actual pipe ID, and obviously change those into a flow rate such the end user can understand. We can then present that information in either a pulsed output, 4 to 20, or any type of output system that the end user is looking for. So the FPI flow meter, or full profile insertion, of course, is a magnetic flow meter, and therefore it carries the same laws of Faraday's law of electromagnetic induction. Faraday's law states that a conductor moving through a magnetic field produces a voltage. The voltage of the field is directly proportional to the velocity at which the conductor is traveling. Hence, why having multiple electrodes in that unit allows us then to be measuring velocities all across the pipe. So no more will we not know what's happening at the bottom of the pipe or in the center of the pipe if you're just using a traditional 1/8 or single point measurement device. The electromagnetic coils within the sensor produce the magnetic fields, and this induces and allows electrodes of the sensor surface to measure the voltage generating by the moving fluid, in this case, water, of course. So the FPI Mag is a full profile insertion style flow meter, which is ideal and really, really key for this type of maintenance or projects or retrofits and areas where we've never had a measurement on a pipe before. The unique combination of the accuracy and the ease of installation that give us a large total cost savings makes the FPI the perfect choice for a wide range of muni and industrial applications. The ability not to have to install a large number of valves or a bypass on a main or even shut the drinking water off allows us to continue to supply our customers at the same time as installing a measurement device on pipes on as large as 138 inches in size or 3.3 meters. It gives us the ability to be able to measure on pipes that we've sometimes never been able to shut the flow off to before. Just to confirm, the FPI Mag is available in sizes from 100 millimeters, 4-inch, to 138 millimeters, 138 inches, sorry, to 3.3 meters in size. It is already approved and tested to the NSF 61 drinking water and NSF 372 low lead approved meters, and it's also RAS approved for the United Kingdom. It's very simple to install and uses a simple hot tap installation using a 2-inch tapping and allows you to insert the meter without turning the water off, interrupting the supply, draining the line down, or in fact, even cutting pipe or welding flanges on. It means that you don't need a crane to lift in a heavy flow meter or other valving or bypass operations. In terms of the specification, I'll just walk you through these very quickly. You heard me just talk about the line sizes and they're written down for you there. So the maximum operating pressure is up to 17 bar or 250 PSI. So that covers predominantly most of the applications you'll find on a traditional drinking water distribution system. The temperature range is from operating from 14 degrees Celsius, Fahrenheit to 140 degrees Fahrenheit, which is -10 Celsius to 60 degrees Celsius. This is pretty much average in terms of what you would expect to see across a drinking water application. Accuracy, the device is 0.5% plus minus accuracy of a flow meter. What this means is you're getting the full benefit of a 0.5 device with all the added benefit of not having to shut the flow off as traditionally you would do to install a full bore meter. So you're still getting the same accuracy. How is this possible? Well, it's those multiple electrodes that we mentioned earlier. A traditional single point or traditional insertion flow meter would have an accuracy somewhere between 2 and 5%. But the issue there is it's very susceptible to flow and would need a much wider and upstream and downstream length. The ability that the FPI has of having the multiple electrodes allows it not to actually need so much upstream and downstream characteristics. So you can get it as close as between 5 and 3, and even less if we know exactly the information that's going on there. We can measure lower flows, less than 1 feet per second. So we can go from 0.3 to 1 feet per second, but that would have a degradation on the accuracy. So that will go to a 1% flow rate. If you're looking for extremely low flows, then that might mean that you need to look for a technology in terms of exactly what you're going to look for. but our ideal is above 1 feet, 1 feet per second, and that will give you a guaranteed accuracy of 0.5%. I mentioned that it's calibrated, each one is calibrated as a matched pair in our NST traceable flow lab. From a warranty point of view, we give a 2-year standard. The unit has uses the tested and certified by the NSF, which is a guaranteed lifetime guarantee on the epoxy which is used, which is a 3M fusion bonded epoxy. And just confirming that the key features. So it's a hot tap installation, so there's no flanges, there's nothing to weld on or put in from that point of view. There's no moving parts. It's maintenance free. Once it's installed, it's literally there. There is no on-site or field calibration required. It doesn't need to come back to us on a yearly basis. It can do bi-directional flow, so both forward and reverse, and it measures all of the full profile of what's going on in the pipe. So it will measure the low velocity towards the top, maybe the high velocity in the middle, and the low velocity at the bottom. It measures everything, unlike a traditional single point that would measure just the flow at the top. As I mentioned, its FPI Mag is RAS UK compliant and certified to NF61 and NSF 372. This is the actual converter, both the ProComm and the ProCom Go, as I've mentioned. You can get standard 4 to 20 outputs, an RS485. So that'll connect directly into DCS, HART, Modbus, built-in verification on the mains powered units for the ProComm, data logger as an option, AMI, AMR smart outputs, again, so Itron sensors as options. This powered option has got an 8-line graphical LCD display, 6-key simple touch programming, and it's an IP68 enclosure. Whereas the ProCom Go? The ProCom Go is a 5-year battery-powered transmitter, so you'll get 5-year life out of the unit. They're D-cell devices, D-cell batteries, and you're able to end-user change them in the field. So it doesn't have to come back to us. It doesn't need to replace on a separate only to us battery pack. You can use off-the-shelf batteries to replace. It's got a passive 4 to 20 milliamp outputs. Pulsed outputs are standard. It's got a data logger built into it as a standard. There's AMI and AMR, again, Itron sensors outputs as an option. It's a standard LCD display. You can communicate with it through a mini USB, and it has an IP67 enclosure, as I mentioned, with the battery power. So a very, very versatile transmitter. The applications in the aging infrastructure we're seeing, well, we're measuring in these really remote locations now where there's locations without power. So, and when we can't get power to them, in distribution networks, reservoirs, trunk mains, leakage management, all the way from raw water intakes, lakes, rivers, abstraction sites, and boreholes. And we're using the FPI predominantly in areas where the customer doesn't need a bypass or a live chamber, or in fact, in our experience at the moment, our customers are using our instruments in areas where they already have a bypass, but it's either broken and they can't replace the valve, or they're too scared to replace the valve or operate the valve. And we're able to install our instruments in existing chambers and existing infrastructure at little or no cost to the end user, compared with removing a full bore meter or removing a large valve, shutting the line off, and going through that whole process of getting craneage in for either the valve or the replacement flow meter, etc. One of the key things to call out with our FPI, it doesn't matter what the material of the pipe is. It's unaffected whether it's concrete pipe, plastic pipe, steel pipe, stainless steel pipe, whether it's MDP, HDP pipe. Our flow meter will simply strap on, insert, and measure the flow which is going through the inside of it. So we know with some other devices, obviously it's limited on what they can actually be clamped onto and put around. But obviously with our insertion device, it will work with any type of pipeline which you're there. So as we mentioned, and that's a picture of one of the largest style FPIs we've done. It doesn't matter whether it's an existing installations and there's no measurement. When you've got problems in terms of pipe layout, whether it's existing bends or different difficult locations, S-bends, things which are close to the pipe, talk to us, ask us the questions. Would your flow meter be able to measure to what accuracy in this difficult application? The way that the FPI really helps our customers is because we're able to work in the existing infrastructure, particularly in this aging infrastructure that we've got in place. We know that end users don't want to take out a lot of equipment that they don't need to. They also know that they've got problems with equipment that's already in place. So there's either existing flow meters that have failed or existing valves that have failed, but they don't want to take them out of their network. So what can you do when you can't shut the flow down? Well, you can install an insertion meter, which means that you don't need to shut the flow off, because we can install under existing pressure on the main and then give you a measurement predominantly within around about 20 minutes of us being able to make the connection on top of the saddle. So that's a very slick, very fast operation, and allows the data and information to come back to you in a very easy way. So just to wrap up on a couple of slides, a few key things to remember. The insertion design of the FPI Mag allows for it to be installed easily across a wide number of applications and pipe sizes. The hop tap installation itself allows you to insert the meter without turning off the water, interrupting the service, taking all of the water out, dewatering, cutting any pipe or welding any flanges. In our experience, some of our customers have been able to save 45% plus on the installation and total cost of ownership versus that of a full bore mag, when compared with how the FPI Mag eliminates the need for heavy equipment, manpower necessary support from a health and safety, installation and maintenance point of view. Because the FPI is delivering to you a 0.5% accuracy, the FPI Mag's multi-electrode design, unique operating principles, delivers accuracy unmatched by other insertion style flow meters and rivaling the performance of the before mentioned full bore mag meters. Let's just look at those specs one more time very quickly. Large size range from 4-inch to 138 is able to cope with pressure up to 17 bar. Operating system pressures across operating temperatures across the normal range from 14 degrees Fahrenheit to 140. Its accuracy, as mentioned, is 0.5, better than some full bore mags. 2-year warranty is standard, and an epoxy ultraliner lifetime guarantee. From the converter's point of view, or the transmitter's point of view, you're able then to be able to get all the key outputs that you would want today. Pulsed outputs, 4 to 20, HART and Modbus as an option. You can have a built-in verification data logger, AMI, AMR. In fact, the ability of our FPI is the fact you can also get the ProComm Go with the battery-powered unit also working with the FPI sensor. You can just decide at the time of what you want to install and which type of transmitter you want to use. So you get the flexibility when you're making a decision whether you want the battery powered unit or whether you want a mains powered unit. These can be specified at time of manufacture to give you, as the customer, total flexibility. Well, that's all from me today. I hope you've enjoyed our Q&A session on the our webinar session, sorry, on remote monitoring using the FPI in an aging municipal system. If you have any questions, I'd be delighted if you want to contact me directly. You can either visit our website on www.mccrometer.com. You can contact your regional McCrometer sales manager. If you want more information on the FPI, please drop onto those links for McCrometer.com, or you can also look on YouTube where you find lots of information regarding our products.
Thank you, Tim. That was a great presentation, a lot of great information, and we would love our audience to also join us on our website to sign up for our newsletters and check out our blog page as well. Thanks, Tim. Thanks, everyone, for joining us, and we'll see you next time.